Alright guys, welcome to lesson 3 where we're looking at our right triangle trig ratios. Today we're going to be looking at cofunctions and similar figures, the ratios of similar figures, the trig ratios of similar figures. So right here, let's take a look at this one, this little warm up. We're starting with right triangle ABC where B is our 90-degree angle. So I've labeled B the 90-degree angle, and I've labeled the other two angles A and C. It wouldn't matter if I had labeled the top angle C and the bottom angle A. It would not have mattered. We know that the acute angles will always be complementary. Remember, all three angles add up to 180 degrees, so if we take out the 90-degree angle, that leaves 90 degrees for the other two. So the measure of angle A plus the measure of angle C would be 90, and then using algebra, I could do 90 minus the measure of angle A would equal the measure of angle C, or 90 minus the measure of angle C would equal the measure of angle A. So if angle A is 30 degrees, 90 minus 30 is 60. If angle A is 45, 45 minus 90 is 45. And if angle A is 22, then angle C is 90 minus 22, which is 68 degrees. So we always have one acute angle and then our other acute angle is always 90 minus theta. We're going to call this our first acute angle is theta. Okay, so if we go to summarize, you can see that if you have angle A as your theta, then angle C is going to be your 90 minus theta. And again, I've just labeled the triangle for visual. Okay, this got cut off over here, I think, on your screen of what you're seeing. So sine of theta, cosine of theta, and tangent of theta. Let's look at how these trig ratios relate to each other. So do not look over here yet on the right. Just look at on the left. So if I take and I make this my angle of interest, my theta, then my other angle is 90 minus theta. Remember, we label opposite, adjacent, and hypotenuse off of our angle of interest. So that's what I have set up here. And that gives us our sine ratio of opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. These are all from previous lessons. Okay, well, what happens if, I'm thinking about the sine, cosine, and tangent of this, but what if I'm on the same triangle and I want to look at those trig ratios of this other angle, and I'm not going to relabel this time. So if I'm here at 90 minus theta, sine is this opposite side over the hypotenuse. Well, that's an A over H. Cosine is my adjacent side, which is now O over H. And my tangent is opposite over adjacent, which is now opposite over adjacent, A over O. So when we look at this, this is sine of one acute angle, opposite over hypotenuse. It equals the same as the cosine of the other acute angle. If I have the cosine of one acute angle, it equals the sine of the other acute angle. And that's what we call our cofunctions. So for our cofunctions, we want to say the sine of one acute angle and we're talking about in right triangles, and the sine ratio, we're going to say sine ratio of one acute angle in a right triangle is always equal to the cosine ratio of the other acute angle. So in other words, sine of theta is always equal to cosine of 90 minus theta, or cosine of theta is always equal to sine of 90 minus theta. Now I want you to look at your tangent ratios. What do you notice? Okay, let's take a look at that stuff. So for instance here, if I say that my sine of theta is 9 over 15 and cosine is 7 over 15 and my tangent is 9 over 7, then I would say that the cosine of 90 minus theta would equal the same thing. Cosine of theta is this, well then the sine of 90 minus theta would equal the same. And if my tangent of one acute angle is 9 over 7, then my tan of the other acute angle would be 7 over 9. If you noticed it in the last slide, they are reciprocals. Okay, so now if I'm looking at this, the sine of one acute angle is equal to the cosine of the other acute angle. Cosine of one acute angle is equal to the sine of the other acute angle. The tangent of one is equal to the reciprocal on the tangent of the other. Remember that they are always complementary angles, so if sine of 15 would equal cosine of 90 minus 15, which would be cosine 75. So cosine of 54 would equal sine of 36. 36 plus 54 or 90. And this would be 68. Is it ever possible that the sine of x equals the cosine of x? Yes. When you have sine of 45, that's going to be the cosine of 45. You can put those in the calculator and you'll see that you'll get the same. And this is for your isosceles right triangle. And that's because the legs are congruent. So for example, if I were to draw 45, 45, 90, we're going to pretend that's right. That means that this leg would be congruent to this leg. If I label each of these 10, done by Pythagorean theorem, that's 10 square root 2. Well, then my sine of 145 degree angle is going to be 10 over 10 root 2. And my cosine of a 45 degree angle would also be 10 over 10 root 2. They would be equal to each other. Okay, let's draw a triangle ABC, where B is my 90 degree angle. Oops, come on. I'm going to make this my B angle. And I'm just going to label A and C. It doesn't matter. You could have done it either way. But remember, sine is our opposite over hypotenuse. Sine of A. So if I make that my angle of interest, my opposite is 6. And my hypotenuse is 10. What is the length of AB? This right here is what I'm looking for. I would use my Pythagorean theorem. I have my x squared plus 6 squared equals 10 squared. Following Pythagorean theorem, I'd find out that my x was actually equal to 8 units. Now what is the cosine of C? Well, the sine of one angle is equal to the cosine of the other angle. Sine of A is the same thing, 3/5. So let's use this to answer some multiple choice questions. So in a right triangle, measure of angle C is 90. So that means that A and B are my acute angles. If the sine of one acute angle is in, then the cosine of the other acute angle is also, this one just says in. this says 90 degrees for this one. It says the cosine of 40 equals sine of theta, then my theta has to be equal to 90 minus 40, which would give me 50 degrees. If sine of 71 is equal to cosine theta, then again I'm going to do 90 minus 71, and it would be 19, which is what D is over here. The measure of angle C is 90 degrees. That means that A and B are my acute angles. Then the sine of one acute angle equals the cosine of B, which is the other acute angle. And another way to write that is 90 minus A. That's the same thing as angle B. So those are my two correct answers. Okay. With these, if the sine of one acute angle is equal to the cosine of the others, I would set them up as equal to each other. And then I end up with a negative 0.6. 0.3 is equal to x. And if the measure of angle C is my 90 degrees, that means that A and B are my acute angles. If sine of A is M and cosine of A is K, the sine of A right here is the same thing as cosine B. Cosine B equals M. And then the cosine of A is the same thing as sine of B. So I end up with M plus K. All right, guys. Go back through these problems, take a look, see if you have any questions. Hit me up either through It's Learning or in class, and I hope you have a great day. I will write these in for you really quickly, just so you have those other options. All right. Have a great day, and I'm going to see you for lesson 3B, where we're going to explore these cofunctions and similar figures a little more.